Guys, here's a quick look at problem number 8 from the 2.1 homework. I didn't get to a detail in class today. Here's an example. So this is one that a student had. Yours might be similar in data, but it said to find the equation or the slope-intercept form of the linear function. So you're going to model it. Well, we did something today with Excel. I thought I'd back it up. If you didn't use your calculator, you can use Excel or Google Sheets, and I thought that might be a good chance for me to use that and explain there's something about this one that's ever so subtle that would throw a lot of us off. That X has to represent the years after 1970. That means 1970 would be 0, 1980 would be 10, 20, 30, 40 respectively. So the way you enter the data makes a difference. And that's a frustration because, so if I were to enter the data in this particular one, this is what it would look like, 0, 2000. So I wanted to give you an idea of what that would look like year and hours, and I put it into a spreadsheet. And I went sideways. It doesn't matter which way you go, but this is years from 1970 as opposed to 1970, etc. And then this over here then is your data for hours that goes with it. Okay, so I'll put hours up on top there. Now, what we did today is we made a regression. If you highlight even the title, and then you go to Insert, and you go to Scatter Plot and hit Enter, it'll plot the data. So that's nice. And then when you right-click or control-click, if you have a Mac, you can get this option for Add a Trend Line. And linear is one of your options. If you want to see what the equation is, you have to hit Display Equation in the chart, and then go find it in there and kind of drag it to where it's visible. That's one way to go at this, negative 10.3x plus 1984. That would be your trend line, and your slope would be negative 10.3. 1984 is your y-intercept. And then it says to interpret those things. So if I go in here and do negative 10.3, I can't hit enter in this point, sorry. I just have to kind of walk you through it. That's the first part that you do for part A. Interpret the slope of the graph. The slope would be, it's always change in y per 1 unit of x. So this would be changing, this would be a decrease of 10.3 hours per year. So this would be a decrease of 10.3 hours, which is our y unit, per 1 year, which is a year is our unit of x. So it's change in y per 1 unit of x, negative 10.3 hours per year, or a loss of 10.3 hours per year. Then you go down to estimate annual hours worked in 2018 is a place where you would put the appropriate year in for x times negative 10.3 and add 1984. And in 2018, for instance, that's going to be, instead of 40, which was 2010, that's going to be 48 years. And so into our equation, we're going to type in 48. And there's all kinds of ways, your regular calculator, whatever it is. Excel is a big calculator. If you type equal, if you go to a cell and just hit the equal sign, it becomes a calculator. So I can actually figure this out, negative 10.3. And then I can type in with a multiply symbol 18, and then I can add 1984. So that's using Excel. It has actually a little calculator in there, but you have to always do the time symbol, which is shift number 8 to get that star. And that'll give me 1798.6, 1798.6. And it does say to enter that to do 2 decimals as needed, I think. But that's the process of that one. Sorry for the confusion. The issue is you don't want to put in 1970, 1980, 1990. You want to put in years since 1970, so that's 0 through 40. And here's the data. I used Excel to do the trend line under Insert and Scatter Plot. And then when I got the scatter plot, I right-clicked on a point, formatted the trend line or added a trend line. I chose linear, and then I scrolled to the bottom and made sure I turned on display equation and chart, and that's the equation I needed. That's one way to go at it. Help is here if you need it. Just send me a note, and I'll send something new.